Hello, my name is Maxim Figat, and with Professor Zieliński we have written the article which already has been published in IEEE Robotics and Automation Letters. Our main motivation is derived from the challenges in robotic system design. Designing robotic system is still a challenging task which requires a lot of skills and experience from the designer. Because of the lack of appropriate design tools and guidelines giving the appropriate balance between the freedom of choice and freedom from choice, the task is still challenging. And one of the solutions is introduction of the model-driven engineering approach, which introduces the patterns in the form of meta-models. But how to define the meta-model for the robotic system? So one of the solutions is the robotic system specification methodology that we have developed, and it divides the whole idea into 4 layers. The first layer is composed of the concepts defining the structure and the activity of the robotic systems, forming the ontology for the robotic system. The second layer defines the meta model for the robotic system. The third layer defines the model, which emerges based on the meta model. And the last layer is the controller code, which is generated based on the model. The main contribution of this article is the introduction of the robotic system specification language, which facilitates development of the robotic system controller. So the whole robotic system is decomposed into intercommunicating with each other agents, and each agent is decomposed into subsystems, and each subsystem has its inner structure. The whole activity of the robotic system is expressed by the hierarchical Petri net. We have introduced the parameterized hierarchical Petri net, which requires from the designer to determine the appropriate set of parameters. But there is a question how to express those parameters. And we introduced the robotic system specification language just to define those parameters. This language is the domain-specific language, which is developed for specifying multi-agent robotic systems, and the concepts in this language are derived directly from the ontology for the robotics, and it facilitates determining the concepts, determining the structure and the activity of the robotic system. The whole idea is divided into 2 parts. So first of all, the designer specifies those parameters in the form of the specification language, and based on the parameterized hierarchical Petri net meta model, the compiler generates automatically the model expressed in hierarchical Petri net form. And then the second part of the translation is performed by the RSHPN tool, which takes the model of the hierarchical Petri net and directly generates the controller code either in C++ or Python for robot operating system. On the top, you can see the fragment of the specification, RSSL specification, which is directly transformed into the hierarchical Petri net. To conclude, we have developed the robotic system specification methodology, and we have verified on several experiments. We have developed the parameterized RSHPN meta model, and we introduced the robotic system specification language, which facilitates determination of the parameters required by the parameterized RSHPN meta model. The observation that we have found that the more complex the system, the greater the benefit of our methodology. And this is because of the reuse. Some fragments of the specification can be reused in other subsystems or other tasks. And it's also because most of the required files are automatically generated. This is especially evident for robot operating system. Our research is expressed appropriately in several articles. The first article expresses the robotic system specification language, the second, the parameterized robotic system meta model, and the 2 last articles, they express the ontology of our approach. Now I would like to invite you to discussion. If you have any questions, don't hesitate to ask.